This is the sixth video in my series on three-phase power transformers. In this video, I'll be looking at delta connections. To be more specific, delta-delta connected three-phase transformers. You can find out more on this subject in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my StanStore at this web address. Now let's look at a delta-delta configuration. In this configuration, one terminal of the primary terminals are connected to the system lines or buses. The other terminals are connected to the adjacent primary terminal. Similarly, one terminal of the secondary terminals are connected to the system lines or buses, and the other terminals are connected to the adjacent secondary terminal. That is to say, the H1 terminals are connected to individual phase conductors, and the high voltage H2 terminals are connected to the adjacent primary H1 terminal. Similarly, the X1 terminal of the secondaries are connected to the individual phase conductors, while the low voltage X2 terminals are connected to the adjacent secondary terminal X1. The transformer having its H1 terminal connected to the R phase, or the red phase, is referred to as the red phase transformer, and likewise a transformer with the H1 terminal connected to the white phase line or bus is green in our diagram, of course, is referred to as the white phase transformer. And the transformer with its H1 terminal connected to the blue phase is referred to as the blue phase transformer. The vectors or phasors look like this, both primary and secondary. We'll put them both up at the same time because they're connected the same way or similar way. The red to white phasors, phase to phase, are shown here. The white to blue phasor is shown like this, and the blue to red phasor, both the primary and secondary, are shown like this. All of these phasors, of course, are rotating counterclockwise. You'll notice that there is no neutral connection in a delta-delta connection. I'm going to move everything slightly here and shrink it down so that I can fit some equations on the slide while looking at the diagram at the same time. And I've rotated the phasors slightly, which I'm allowed to do as long as I maintain their relativity. For a delta-delta connected transformer, the turns ratio is given by the primary phase-to-phase voltage over the secondary phase-to-phase voltage. That is because the phase-to-phase voltages bridge the entire coil of each of the transformer legs. In coming up with a per-phase equivalent circuit for this type of transformer, the first step in the procedure for a per-phase analysis is to convert all delta loads and sources, and the transformer is a source in this case, to their equivalent Y connections. The neutral, of course, is hypothetical because there is no neutral in this connection. However, it can be calculated by referring to the three-phase phase relationships because we're talking about a balanced condition here. So, again, we can use the phase relationships to come up with a turns ratio using the hypothetical phase to neutral voltages. Then write that phase to phase turns ratio in terms of a line to neutral voltage. We can now construct the per phase equivalent circuit using the hypothetical phase to neutral voltages. The phase to neutral primary voltage can be calculated from the phase to neutral secondary voltage by multiplying by the turns ratio. Or If current is flowing in this single phase transformer, the secondary line current can be found by multiplying the primary line current by the turns ratio. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. Some of those products include EcoFlow's big and small standby generators. This is the best time to try out any of EcoFlow products because they are having a huge sale starting on April the 4th and lasting until April 21st. Here are just a few of their products, starting with the EcoFlow Delta Pro Ultra, including the River line of smaller standby generators. And a range of portable solar panels. And finally, a unique product, the Wave 2, which is a portable air conditioner / heater. As I said, this is the best time to try out any of EcoFlow's products because it is having a huge sale starting April the 4th and lasting until April 21st. During this time, you can experience huge savings off the original market price. To obtain more information on this subject and pick up your free digital copy of the Ultimate Guide to Residential Standby Generators, simply fill out the information requested when you go to this website, https://lowercase bit.ly/4/4_a_D_X77. Before I end this video, I want to repeat the connection to obtain my free copy of the Ultimate Guide to Residential Standby Generators and receive access to the major April sales on many of the EcoFlow products. Also, here is a connection to obtain a free copy of my 50-page electrical power crib sheets. And finally, here is the link to all of my electrical courses, which are located in my Stan Store.